Now, dear students, so in previous class I have discussed all the formulas. So now I am going to discuss the numericals related with this formula. Now see how we can write or how we can calculate the frictional force, different types of forces with the free body diagram. Suppose you have given one diagram. So one diagram, suppose question is here. Question. Suppose you have given three connected bodies here. You can see very carefully because you have to make first free body diagram. After that you have to segregate the formula. Then only you can solve. Otherwise it will be very difficult for you. Now if we consider mass, I consider 2 kg. And here you can see the object is bigger than this one. So I consider it is 4 kg. And here I consider 8 kg. Now see, these all three objects, all the three bodies are contact with each other. So when force is applied on the body, suppose here force is acting. So here force is acting. That means I consider 10 Newton force is acting on the body. So when the force is acting on the body, acceleration will be like this, forward direction. So when accelerate into forward direction, then we have to calculate the value of tension T1 and T2. So how we can calculate the value of T1 and T2 from the given diagram? So we have to calculate the tension. We have to calculate the forces, contact force. So here you see, first you have to write in the form of free body diagram like this. The first one, it is given 2 kg. When force is acting this one, I consider here F1. Similarly, there is a kind of body and here force, it will be F1 and it will be F2. And here it will be 4 kg. But in the third diagram, you can see, in case of third diagram, you can see here 8 kg body object is given. So in this case, you remember this is F2. So acceleration into forward direction. So we have to write the formula F minus F1 is equal to twice E. First formula. Second formula, F1 minus F2 is equal to 4E. And you can see the third formula, it will be F2 is equal to 8E. Because when applied force acting forward direction, the direction of the acceleration will also forward direction. So that is why we can write like this. So according to our question here given, the value of applied force here given 10. So it will be 10 minus F1 is equal to twice E. Here twice A. So here you can see we have to calculate the value of F1 and F2. So from the given diagram, how we can calculate the value of F1 and F2? Already you know three equations are given here. So this is the equation for the first diagram, and this is the equation for the second diagram, and this is the equation for the third diagram. Now you can see this part we can write. So F1 is equal to 10 minus twice E. So if you put here equation number 1, equation number 2, equation number 3, you just give. So from the first formula we can write. So now we put from equation 2 we can write F1. F1 means 10 minus twice E minus F2 is equal to 4E. So in this case we can write 10 minus 6E is equal to F2. That means the value of F2 is equal to, what is the value of F2? F2 is equal to 10 minus 6A. Now from equation 3, value of F2 is equal to 10 minus 6A is equal to 8E. So in this case you can see the 10 is equal to 14A A is equal to 10 by 14. So this is meter per second square. This is the acceleration. Now, if you put the value of A in equation number 1, you will get value F1 or F2 like this. So now, so we are getting the acceleration is equal to 10 divided by 14 meter per second square. So this value we can put in equation number here 3. So from 3 we can get F2 is equal to 8E, that means 8 into A. A means 10 by 14. So it will be 18 by 14. It will be 40 by 7. So it will be 50. That means 5.7 Newton. So for the first, from the third equations, F2 we are getting 5.7. Now from equation number, from equation 2, you can see equation 2 F1, we have to calculate the F1 minus F2. What is the value of F2? 5.7 is equal to 4 into A. What is the value of A? 10 by 14 like this. So we can solve easily. F1 is equal to, so it will be 40 divided by 14, and here it will be plus 5.7. So it will be 2.7 plus 5.7. So it will be 14. It will be 8.4 Newton. So dear students, you can see from the given diagram, according to our questions, we have to calculate the value of contact force and the acceleration. So the F1 value, so final result we are getting, this is the F1 value, and second result we are getting F2 is equal to 5.7 Newton, and third one is acceleration is equal to 10 by 14. So meter per second square. So using such process, you can easily find, according to our questions, if the frictional force or contact force is given between the objects, then using this formula you can easily try to solve. This is a basic formula, basic idea. Now you can see one more diagram I am showing you, when the diagram it is in contact, but when the diagram is connected. Now see, when the diagram, that means bodies are connected, that means if you consider like this, here M1 means 1 kg I consider, and here 2, M2 is equal to 3 kg I consider, and here M3 is equal to 6 kg. So M1 is equal to 1 kg, M2 is equal to 3 kg, and M3 is equal to 6 kg. Now when here suppose 10 or suppose 20 Newton is acting, so here it will be tension, and here also you can see it will be tension like this, here T, here T1. So if the force is acting backward direction, the direction of acceleration will also like this. Therefore, you have to make the free body diagram. The first diagram you can see M1 is equal to 1 kg. So force 20 Newton left side, and here tension will be right side. So from the free body diagram, it is clear that 20 minus T is equal to M1 into E. That means 20 minus T is equal to 1 kg into acceleration. That means 20 minus T is equal to A. So T 20 plus A is equal to 20, equation number 1. Now see, for the second diagram, that means if you draw like this is the second diagram, that means here 3 kg. So, and force here tension T and here tension T1. So, in this case, T minus T1 is equal to 3 into acceleration E. So, we can write here, T minus T1 is equal to 3A, equation number 2. So, for the third diagram, it is very essential, it is very important how we can find, how we can write, and how we can divide, and how we can write the equation with respect to diagram. It is very important. So, now the third one, you can see the third one, it is 6 kg. It is given 6 kg. So, here diagram will be for tension force. This is this will be like this. So, from the given diagram, it is clear that T1 is equal to 6A. T1 is equal to 6A. Now, give equation number, it is 3. So, students, you always remember, we have to calculate the value of T1, we have to calculate the value of T2, along with we have to calculate the value of acceleration. Therefore, we have to solve it. Here given T1, so from equation 2 we get T minus 6A is equal to 3A. So T is equal to 9A. We are getting 9A. So T is equal to 9A we are getting. Here put from equation number 1, when we are getting 9A plus A is equal to 20, then 10A is equal to 20, A is equal to 2 meter per second square. So, after solving equation 1 and 2, that means you have idea about the linear equations you got in class 9 and 10, how you can solve linear equations. Suppose you have given x plus y is equal to 3, x plus 2y is equal to 5, and x plus 5y is equal to 4. These are the linear equations, and from the linear equations, we can easily calculate the value of x, y and z. Similarly, we have used here 3 equations, equation number 1, equation number 2, equation number 3. So, using equation 1, 2 and 3, we are going to calculate the value of tension T1, we are going to calculate the value of tension T and acceleration due to an acceleration. Now, you can see after solving, we are getting acceleration 2 meter per second square. So, this is very important. Acceleration A is equal to 2 meter per second square. Now, you just put the value here. So, T is equal to 9 into 2, it will be 18 Newton. So, we also calculate the value of tension T, and which is given 18 Newton. Now, another value we have to calculate, the value is T1. So, from the given T1, from 3 equation number, from 3, we are getting T1 is equal to 6 into A, 6 into 2, it will be 12 Newton. So, dear students, you remember how to solve. This is very important part, because one question will come related with this in your entrance exam. So, that is why the conception is very important for you. So, how you can write the body in different way, that means free body diagram, and from the given free body diagram, how you can write the equation, it is very essential, very important. Then only you can solve the problem. Now see, I have solved the problem. So, from the given 3 equations, I have calculated first T1, again T2, again acceleration. Next, you can see, suppose you have given one more diagram is here. So, one more diagram you can see here. Suppose the diagram is given like this. So, numericals will come in this way. Suppose 2 object here, 2 object is here. This is M1, and another object is here M2. So here force is acting here F. This is the applied force. So due to the applied force, one frictional force is there, I consider, or frictional force you consider F. Frictional we consider F. So in this diagram, you always remember the frictional force, normally it may be given here, or frictional force it will also develop here. So that is why you have to remember this diagram in this way. So this is a applied force, this is a frictional force. So in this case, what you will do? In this case, first you have to calculate the value of F. So already you know F is equal to mu and weight N1. So F is equal to mu N1, that means M1Z. This is the value M1Z. So here F, the value of F is equal to, given here mu M1Z. Now you remember, when we are talking about all the two objects, or when two objects are placed like this, what is the total force? So total force in this case, you remember, total force will be, in this case we can write this one F1 plus F2. So in case of F1, we can write mu M1 plus M2 into Z. Mu M1 M2 plus Z. So this is the total force. So that is why you remember F is equal to mu M1 plus M2 plus M into Z. So if you are going to use this one, from here we can write the value of mu. We can write here mu is equal to F by M1Z. So we can put like this also, otherwise we can keep in this way also. So you have to calculate the value first, that means F is equal to mu M1Z, and here total force will be like this. So this is the idea about the forces, that means these forces will act on the body. So total forces will be F is equal to mu is equal to M1 plus M2 into Z. So in this way we can easily calculate the forces. So maybe given three body. So in case of three body, suppose you have given one more body is there. So the forces will be mu M1 plus M2 plus M3 into Z, and here you have to consider F is equal to mu M1Z. So in this way we can easily calculate the value of force. Normally you always remember, suppose Pulley diagram. In case of Pulley diagram, in case of Pulley diagram, you remember, suppose this is a kind of pulley, and object is here one, suppose like this. So there is a tension, it will be in this way. Suppose this is M1, suppose M2. So when force is acting here, suppose F, so tension will generate here T, and here this T will be here like this, and a kind of frictional force will develop here. So in this given diagram, how we can write the formula? Basically, for the body M1, so for mass M1, for mass M1. So for mass M1, you remember F minus T is equal to M1Z, M1Z, and here for mass M2, for mass M2, it will be T minus F is equal to M2E. So dear students, you always remember why I have written F first, T second, here T first, small f second. The meaning is that this is called tensional force, and this is called your applied force. So due to the applied force, tensional force is developed. So this force is a primary force and this force is a secondary force. So that is why primary force minus secondary force, and the body is acting vertically. So that is why we can write M1Z. And if you write A, also we can write A. A is equal to Z, we can write like this. Similarly, in this case you can see the frictional force is developed. When the frictional force is developed? After apply the force. That means if there is no any applied force, there is no frictional force. So that is why the applied force is here T, and here there is a frictional force. So that is why this is a primary force, this is a primary force, this is a secondary force. That is why you remember, in case of primary force and secondary force, it is very important. So due to the primary force, secondary force is developed. That is why T minus F is equal to M2E. So in this way, we can easily write the relations, and from the given relation, we can easily calculate the value of tension, calculate the value of acceleration, we calculate the value of applied force. So we can easily find out all the values after knowing this formula. So first you have to remember this, which one will be primary and which one will be secondary. So dear students, you always remember, when the force is applied on an object, on a thread, then due to the force, tension will be created on that particular thread. So here applied force will be the primary force and the tension will be the secondary force. That is why you have to remember the primary force minus secondary force. That means you always remember this one, primary always bigger and secondary always smaller. But don't write tension T minus applied force. It will be wrong, because without applying force, it is not possible to develop the secondary force. So that is why you have to apply the force. That is why F minus T is equal to this one. So always you consider the primary force. Due to the primary force, secondary force is developed. That is why primary force you have to write fast. So in this way, all the formula, using this formula, you can easily solve the numericals. So this is the idea about the friction. So one numericals will come related to the friction. So you have to just, I have given the basics revision of the chapters. So you will remember all this formula related with this, then you can easily solve. So dear students, for today I want to stop, and you always remember, you have to practice all the formula, you have to write all the formula along with the physical significance of the formula. Every day I am telling you, you should know the physical significance of the formula, then only it is possible to solve the numericals problem. So when you are going to prepare this chapter, so at first you read your textbook, after that whatever formula I have given here, so you have to write, and write 2 or 3 times, then it memorize and you apply in the numericals problem. Thank you. Thank you everyone. Okay.